Hey everyone, Joe here. Do you ever have those topics that you just hope to talk about someday and you're never sure if you're going to get to it? Well, I get to do that and do it on the air with this podcast.
Welcome to STEM Punks.
Welcome to STEM Punks. STEM Punks is a bi-monthly podcast intended to bring science,
technology,
engineering, and math straight to your ears from our STEM Punk studio. Hang on, we'll take you for a ride that includes a whole lot of fun and a little bit of education on the side. Stay tuned.
Nice to be in orbit.
Welcome everyone to the STEM Punks podcast. My name is Joe Garut and I will be your host. And with me as always is my buddy STEMBot. Hello STEMBot.
Hello, Joe.
STEMBot, it's been far too long since we've been on the air and I'm really glad to be back.
Oh, me too. I have a bunch of data I want to share about...
Wait, STEMBot. It's not time for that yet. Beep, boop, 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 boop. Today on STEM Punks, we're going to talk about LEGO robotics.
Oh, Joe, you know that's not what a robot sounds like these days.
Really, STEMBot? What does a robot sound like?
Seriously?
You must mean something like this.
Listen to me very carefully. Cyberdyne Systems Model 101. Trust me.
Danger, Will Robinson.
Never fear while Rosie's here. Ta-la-la, ta-la-la.
Joe, I never sound like that.
I bet you could if you tried real hard.
But Joe, those are just voice actors doing those robots.
Quiet down, Shorty.
That is Rosie the robot from the Jetsons. She debuted in 1962. She doesn't sound very modern at all.
You're a feisty little one, but you'll soon learn some respect. Fit him with a restraining bolt.
What can you expect from wiring as old as mine? Well, thanks for the chance.
Might be doesn't.
All right, buddy, I'm just teasing. We have a great show about LEGO robotics, and I'm really excited because I have been a LEGO fan my whole life. Without going into too much detail, I made LEGO creations of all shapes and sizes. I even remember taking photos of them, convinced that I would be able to send them in and have my models end up in a box somewhere on a shelf. That obviously never happened, but it's probably a good thing because here I am getting to do this podcast instead.
Yeah, Joe, and then where would I be?
Well, you might be a LEGO robot. But anyway, before we go too far down that path, let me just say I'm ready for this interview, and I hope you all are too. STEMBot, would you cue that up, please?
Okie dokie.
I've got two guests with me today, and would you please both introduce yourselves? Oliver, why don't you start?
My name is Oliver Yue. I'm a 13-year-old student at Wildwood Academy, and I'm on the FLL robotics team, the Snacketeers.
All right, and you, sir?
All right, my name is Jim Yue, and I am 40 years old, and I was an assistant coach for the Snacketeers this year, and Oliver is my son.
You lead robotics club, one of the teams, right?
I'm actually one of the coaches. We have multiple coaches. So
how many coaches are there?
We have 5 coaches.
Is it part of a school function?
We do it through Wildwood Academy, which is a small school that started up a couple years ago over in Hood River. And it's a school-sanctioned team, but it operates kind of separately. So we use the school's resources, like the room. They help build a table for us. They support us. They sponsor the team. But the team itself is kind of an independent body. So I think it's like that for most schools. It's kind of like an after-school function.
Gotcha.
Yeah.
Gotcha. Now, the Gorge Tech Alliance, they just did a blurb. Jessica Mehta wrote a thing about the robotics competition that occurred in December, and there were 2 different dates, right? The 7th and the 14th. Can you tell me more about that competition? Oliver, how about you?
Well, a lot of the times when they're in the competition, most people think when it's called robotics, obviously, but they phrase it as FLL because there's 3 parts to each competition.
And what's FLL?
So FLL stands for First LEGO League. So this program is created by LEGO, and it's meant to kind of foster STEM at an early age. So they divide First LEGO League into 3 parts. So They have a project part, they have a robot part, and they have a core values part. So the project part, what they have you do every year is you find some sort of issue with the world. Now, usually they'll give you a kind of topic that you have to stick to. Last year's was space and some of the problems that people have in space travel, and this year's was public and community work. So something in your community that you think has an issue to it, and how would you solve it? And so they will assign all of the groups this problem, and then everybody has to pick an innovative solution to solve whatever they picked. So for example, our group this year, we picked the problem of affordable housing in our community. So the median home price in Hood River is about $400,000. So
Wow.
That's pretty unbelievable. So yeah, you have to come up with a solution. They look for something that's unique, something that hasn't been done yet, or if it's been done, it's a big innovation on a solution. So they look for that in your project. The robot part is the part that a lot of people, I'd say people know the most about. You start with a base model of a robot that Lego provides, and then you work on your robot, you add attachments, you add wheels to it, and there's essentially a big game board, you could say. And there are different missions set up on the board, different tasks that give a certain amount of points based on maybe how difficult they are. And you have to take your robot and engineer it, add certain parts to it to be able to complete these tasks. You also have to add a factor of programming, controlling the robot to do these tasks. And they can range in difficulty, be very hard, very easy. But obviously, that strains the amount of points you'll get for either one.
Okay. So that's great, man. That is a lot of information. So let's unpack it just a little bit. I'm really curious about how the housing problem ties in with the robotics thing. I mean, are they directly related in what your project is?
They take the theme of the project and they put it into the robot game that they do every year. So it will be themed around whatever project problem.
It might be like, how would you get a robot to stack bricks to build a house?
Exactly.
Okay.
An example of one of the missions would be like having wildlife in a certain area. That was one of the missions. You had to move the animals, they make little Lego pieces that you have to build and construct, and so you have to move those, for an example, as one of the missions.
All right, I get it. And then the other thing I wanted to touch on was you talked about the programming, and is that coding?
Yeah, coding, I'd say, is the right term. Lego, since they're running the entire event, we use they have a program that we use for their robots in EV3 coding language, so it's kind of like a separate thing. It's not exactly like lines of code. It's more of like, if like a snap block line of code, like you can input a certain amount of centimeters and you just snap the lines together, and you can create custom lines, like a custom block that you can snap onto another one.
And so where coding, of course, I'm drawing back from years and years ago when I used to program in BASIC, and there were statements like if, then, and what have you, from, to. With this, it sounds like it's more visual based when you say snap the line.
Definitely more visual based. A lot of the different things, instead of having to like type them out and know them, they're organized by color. So they're kind of sorted through different sections. Maybe like something to repeat, you would go under a certain section. Or if you could create a custom block, like a subroutine, you could create one of those and then be under a certain color.
Okay, and for those who don't know what a subroutine is, that would be just a command that would say, if I know that I want to make a left turn around a corner, it might be forward 1, turn left, forward 1, and then now I can make that as a routine that every time I want to go up and turn left, then I just insert that in and it does those 3 steps, right?
Exactly. Right. It saves you a lot of time.
Okay, all right, cool. For those of you who are out there listening that have children, there's a great hands-on version of this type of coding in a game called Robot Turtles, and I'll put a link in the show notes. Stambot, would you put a link to that in the show notes for me?
Okie dokie.
Great, thanks, buddy.
Well, what's also really nice about these little coding blocks is that What they'll find out is that they'll program the robot to go forward 15 wheel rotations and then turn 90 degrees to the left. Well, let's say that the measurements are really a little bit off and they need to go 18 rotations. Instead of having to go in and rewrite the entire line of code, you can just switch out those numbers and the algorithm will switch it so that it runs that program all the way across.
Makes the change all the way across.
Correct. So you do, you can just change the distance or change the number of rotations, and it'll basically correct it for the entire program.
If you've put it in the subroutines.
Correct.
Gotcha.
Yeah.
Okay, let's move on. The third component you were talking about in the FLL was what again?
So they call it core values. So, for an example, it's a set of about, I'd say, six different aspects of life that they want you to express throughout kind of your career as a team and at the competition. So it'll be something like teamwork, cooperation. I mean, that's
right.
Cooperation.
Cooperation?
Which is a portmanteau. It's a portmanteau of cooperate and competition. So they want to do, it's basically friendly competition where you coordinate and collaborate and not just kind of shove people to the side.
A word that comes up a lot is gracious professionalism, where it's being a good sport. It's kind of a glorified way of saying being a good sport and being respectful of the other team while still having some friendly competition thrown in there.
Gotcha. I like portmanteau. That's a good word.
Yeah.
Do you guys follow a script basically that Lego has created in this, or is there a lot of input that comes from?
So let's just break it down to brass tacks, is that all kids want to play with Legos.
Right.
All adults want to play with Legos. And I think the Legos and the building and doing the missions is kind of like the gateway into FLL, first Lego League. And then the core values and then your project is for most kids, I think they consider it as kind of like a secondary, tertiary thing where they don't want to do those things. They just want to build Legos, and they want it to run up and down the game board and raise flags and throw things around and knock things over. And that's fun. But what we have found out doing this for many years now is that the project is the time when the judges really get to see them break out of the box and really start thinking ahead and thinking, well, how does playing with these little plastic bricks apply to the real world? And how do we do that in a team, or how do we do it in our careers going forward? Because they're learning super valuable skills that I wish I would have learned at their age, cooperating, discovering, doing research, putting together presentations, working together as a team. So it's very easy when you've got like the kid whose dad does programming, for that kid just to do all the programming, right? But that's not what teamwork is about.
Right.
So we found that those who were a little bit more adept at doing certain parts, like maybe building the robot or programming the robot, that they became mentors for those younger kids or those who are newer to the program who didn't have those skills. So we did a lot of rotation. No one ever wants to do research and put together presentations, so we had all of them do that as well. And I mean, on our team, I think a lot of our coaches, since they've gone through the program, are also are heavy hitters in their own right as professionals, right? So they have a lot of project management skills. We had people who, I mean, what they do is they just work in tech. And it would be easy for them to come in as programmers or engineers and just do everything for the kids. But I think one of the hardest parts being a coach is just not getting in the way. I think that was the hard part. That's the part of coaching which I think was the most difficult, was just letting them do the work, setting them in direction, saying, this is what needs to be accomplished. This is your timeline. If you need help, let us know, but you've got to do the work.
Right.
Yeah.
Right. And so how long have you been doing this, Oliver?
I've been doing this for about 5 years.
Okay.
So
how old are you?
I'm 13 right now. And I'd say the first 3 years were probably some of the worst, definitely.
Really? Why is
Yes. Well, the team we were on, a lot of as previously stated, a lot of the times kids just kind of want to fiddle around and play with Legos. Like, they don't have this enormous expectation of there's going to be a lot of responsibility involved in it. They see the word Lego and they just go crazy.
They just think it's going to be, I'm going to go build this robot. It's going to be all kinds of fun.
And they are 8 years old.
At that point.
Exactly.
Yeah.
Mm-hmm.
And so there's not, you're
But
obviously,
I take it you weren't that way at that time.
I did still have a little bit of that in me, but I say I was more focused than a lot of people on my old team.
Okay.
Well, plus your mom would yell at you too.
That's true.
That's good.
But having
was
done it,
mom the coach?
Mom was
yes,
the coach.
she was.
Oh.
but having done it for 5 years, I mean, you've got a lot more experience. You've got more maturity.
Exactly.
Certainly. I mean, do you feel like that being 13 and being in this has made you more mature and more thoughtful about things differently than you might have if you hadn't been involved in this?
I definitely do think it has. I think especially Lego pushing the core values aspect of the entire program has really set me to think in standard teamwork situations and other aspects of life, really have some empathy for the other people and like understanding. So core values has definitely intruded its way into other parts of my life.
Your dad didn't just tell you to say that, right?
No, I've actually tuned out for a moment. But what I will say is that I think the largest contributing factor to their success is because of the incredible failures that we had as a team in those early years.
I'm so glad you brought that up because that was in our list of things to talk
It
about.
is.
Yeah.
Oh, I mean, it was like crash and burn failures where everything was on fire and no one was going to escape. You know, it would be.
Now, do you mean literally on fire? Or do we need to be worried about these?
No,
clubs?
no.
Okay,
There was no heat involved.
Okay, all right.
Other than emotional.
So you just mean that it was some major catastrophe in the way that something wasn't coming together the way you wanted it to.
Oh,
or needed
absolutely.
it to.
So we had, when my wife was coaching, it was just like a dumping ground for kids, right? Because, that's what some of these clubs are, is like, hey, you just watch the kids for a couple hours and they're going to play with Legos and then we come pick them up and you can give them a snack. But without that parental involvement, it's hard to control other people's kids.
So what has changed it? You mentioned getting more parent volunteers. Is that what changed it from what it used to be into what it is now, which sounds like a more organized and constructive type of a club?
No, how would you answer?
Oliver's got it.
Yeah, go ahead.
I think it's because the teams in the past, most of the time we had known each other for a while, so there was already kind of like a group dynamic where you would act more like a friend instead of like a valuable teammate. And this new team, since the school we were going to was on its first year, none of us knew each other, so we kind of had to build our relationships on being a valued team members of each other.
So you are saying that in the early, you've switched venues now is maybe the biggest thing. I see.
Wildwood Academy.
Yes.
Right. And it wasn't like we were here in the Gorge before that. We lived in Columbus. And I think the issue was...
Okay, so all this stuff happened outside of the Gorge.
Exactly.
Okay, so for those listeners who are checking this out, none of this happens in Hood River.
Hood River is a very unique place to live in, and it's got some really cool, good vibes that we're happy to be here.
I want to get back to a question that I had, though, if I may. One of the things that the LEGO System for Learning mentions is the 4C framework. Is that familiar to you guys? Mm-hmm. So here it talks about the 4 phases are connect, construct, contemplate, and continue. Is that something that you can speak to, or is it different in your club?
The 4 pillars are just kind of always there. They're the foundation that we build everything else on. But the work itself is focused on the project, the core values, and then the missions, which involves the robot and the building and adding of attachments and making sure that it goes straight and it turns here and then it turns here and not, but those all kind of work in tandem. And people may want to focus on just doing the missions, which is fine. But I think we felt comfortable enough with our previous experience doing the missions, building the robots, doing the programming, that we focused a lot more on the project and the core values, because we realized that even though they're all weighted equally, that that the other two kind of fit together.
And maybe the other one would kind of take care of itself. And when you say missions, you mean the actual task that you're building the robot to do and having it do it. That's the mission.
Correct.
Which is part of the Lego script. Basically.
Exactly.
Yeah. One thing I don't want to forget to ask, Oliver, is I'm hearing you get a lot of good things out of the core values and, out of all aspects of doing what you're doing. Do you see the things that you're learning doing this Lego Club affecting your choices for what you're going to do in your adult life?
Oh, definitely. I think a lot of as I said, it kind of fosters like early STEM work and a lot of other things in that kind of sense. Absolutely. Like programming, obviously, it's a very baseline version of like programming, but it could like spark the flame for other kinds of programming jobs. It's definitely a very good gateway into all of these other kind of things. I think especially for me too.
So how? So tell me, what are you thinking about for your future?
I think a lot of programming. Like I'm really infatuated with kind of like video games and like different types of software, a lot of computer parts. So I think this programming, I'm taking other programming classes in the summer too. So I think FLL kind of jump started that for me. If I'm being honest.
So you'd like to be a programmer,
yes.
possibly? Yeah.
Yes.
Cool.
Oh, please be a programmer.
What other programming languages do you know about?
Python. Is it C++?
Yep.
Mm-hmm.
That's.
But you obviously haven't dabbled in that one yet.
No.
How about Swift?
Swift, I've heard a lot about. Actually, one of our team members' parents is a fluent programmer in Swift, and they're going to teach a class at the school, so I'm going to learn that.
I've done a little bit with it, and I recommend it.
Oh,
yeah,
cool.
it's a pretty easy thing to just jump right in and get started with, and it's a low to no cost investment to actually start on it on your own and try some things. You can just immediately see the results on your iPad or on your iPhone as you build it. You can go into the workspace and make it, and then just transfer it over and try it out. And yeah, it's pretty cool. Yeah. What's the name of your team?
Our team name is the Snacketeers.
Snacketeers. I was looking to see if you were in this list of all these.
Are they top?
Yeah, we are. I think we ranked. I think we were number one going to state this season.
It had you and the other one's called.
The Robobs.
Yeah, and it just so happened that the Robobs contains a team member that is Oliver's cousin.
Oh, cool.
So, hey.
Cool. Keeping it in the family.
Small world, right?
So, yeah, I see, all right here then, overall first place champions to your team and the Robobs. Oh, that's super cool.
Yeah.
That is super cool.
That's pretty awesome.
Congratulations.
Oh, thank you.
Yeah.
Where are the Robobs from?
Hood River.
Hood River.
Yeah. Well, you know what? Something I don't think we've touched on yet is what our actual project was.
Well, and I was going to ask that. So this is the championship winning project, right?
Right.
Yeah.
This is the championship winning project. When I was really amazed at how it came about. So we looked at homelessness or the lack of affordable housing in the Columbia Gorge area, specifically Hood River.
Right. As a team, we went through some trial and error and decided a cohesive solution. We kind of threw in different bits and pieces of an idea until we came up with one cohesive one. So our idea ended up being, if anybody knows or seen Ready Player One or Reddit, there's something called the stacks. It's essentially like an apartment complex stacked up of different containers that people live in. Our solution was a slightly more organized idea of that. What we would do is it was a modular shipping container housing system.
Oh, cool.
So we would have a frame, a steel frame, and then we would take existing shipping containers and format all the plumbing and electric connections and renovate the inside, insulate it, and then put them on these shelving units to form one cohesive kind of community as such. And there would be an elevator on the units for access to other units. And one of the perks of our units with B is that the units are transportable. So if you wanted to move, you could take them out and put them on some kind of moving truck for easy transportation.
Oh, because they're made in shipping containers anyway. So you just pick it up, put it on a flatbed, and take it to Akron, Ohio.
Exactly. Exactly.
Naturally durable too, since they're made with army grade steel.
And then once you get there, you'd stack it back up, create that vertical height again, so that you can have a low overall footprint and get a lot of people in.
Right. And we talked to a lot of city, like Hood River City Planner, Wasco County Commissioner. We had a lot of experts come in. I think that's part of the great programming, is that we're encouraged to invite experts in a certain field to come in and not only give out tips, but kind of evaluate a project as it develops. And one thing that we kind of looked at after we had already gotten it started was that there's a large migrant population lives in Hood River. You know, they come in, they pick fruit, and then they go back. We've noticed that those houses don't have plumbing. They also don't, they have very rudimentary like electrical services, and they're just kind of there just to stay. And we kind of took that as kind of a jumping off point, saying, well, that could help with affordable housing, but it could also help with migrant housing as well as people who just come up and want to hang out and go ski. It's modular housing that can go sit in an orchard. Could also be in the cities. We thought it'd be a good idea for it to be in colleges, so that kids who are moving into dorms, they could just take their shipping container from home and then move it into a stack on campus and still have all their comforts. Because I think though people are doing that now, it's all one-offs, right? It's all people who have construction backgrounds, takes a Sawzall and starts cutting holes in it, putting windows in. There's no standardization. So their innovation within that would be to standardize all the fittings and electrical connections on one end of the container, so that once it slides into place in the structure, it's very easy just to kind of hook up all your utilities on the back end.
And when you say their idea, you mean the team.
Correct.
Yeah, your team's idea.
Because our job as the coaches and the experts' jobs were, okay, well, this is your idea, but how are people going to run their dishwashers? Or how are people going to go, wash their hands? Or how are people going to make food? So that's what questions that we had to ask that kind of elicited more thought from them. And, and then experts.
But as you say, everything's standardized. So even taking that shipping container, it almost could just plug right into everything because the hookups on both ends.
Right. One of our team's favorite analogies is just saying it's kind of like plug and play, because you just kind of slide it in there and it's functional. So
it's it's a very Lego concept.
Yeah, no kidding. It is a giant Lego brick.
Yeah.
And so then you had to create some sort of Lego project to do that kind of thing.
Yeah. So we took the team took the Legos and they built a structure, and then they printed out using we used a 3D printer to create small scale models of what the shipping container would hypothetically look like.
Whoa. So you made a shipping container with your 3D printer?
Yes.
Oh, that is cool. Okay, go ahead.
More than one.
A scaled one, not a full size.
Well, right. Thank you for clarifying. Okay, so you made a mini one.
Yes.
Yeah.
And we built the entire frame that we were talking about out of Legos, so we figured that would maybe be like a hit off with the judges, connecting it all back towards Legos. And so it would be interchangeable. We made them slide in. We put a little lock on the front so they wouldn't slip out. Obviously, it was all not 100% polished. Like, it was still kind of rough on the edges. Like, it wouldn't be an exact representation, but it was a pretty good one.
But it definitely demonstrated your project.
Yes, it did the job.
And then what was the mission? What was the Lego mission?
Oh, so we had multiple missions. So I think, how many missions were there total? Maybe 12.
Oh, wow. Okay.
And we ended up successfully completing 5 or 6?
I believe 5 was the right number. The real struggle with the missions is trying to get as much done. They give you a finite amount of time. So that's.
Do they give it to you on the day? Or do you get it ahead? You have it
we have it
ahead of time.
You get a replica of the practice board that you can assemble. You have a mat that you lay down, and then you construct all the exact same missions yourself, so you can practice with your team.
I see. And I've seen some of these where there's a combination. Some of it is all automation, and some of it is manual, and some of it's a combination of automated and manual. Is that the way yours operates, or is that a different level?
Yes, that comes into a certain level of the main way missions are done is by adding attachments to the robot. So you'll always have to start with like a motor that you put on there.
That makes it roll or whatever.
Right.
Okay.
And then obviously you'll have to go in and add programs, so maybe like motor rotations. And
Maybe
a lot
of catapult arm or something
right,
like that.
Right.
Yeah,
a lot of the manual part is being able to switch sort of pieces or lock something into place. Alignment is a really big thing because your robot has to be in a very precise position to do a lot of the missions. Like if you're maybe half an inch off, it won't work correctly, or it maybe won't return to your spot as intended.
I think most people think of automation nowadays as kind of like flying a drone, right? Where you have a screen and you get to kind of pilot where it goes. So we can't do that. All the programming has to be done beforehand. So we have to take all the measurements, program everything in, and then the onus is up to the proper programming that we did to get it to go 15 rotations forward, turn 90 degrees, and then go another 5 rotations, and then turn around and come back home. So it's not, I mean, if you can think about it as kind of programming those first lunar missions, right, where you had limited contact with the rover itself, you just had to tell it to go a certain amount of paces and hope that it didn't fall into a crater somewhere. So that's a lot of the programming of the robot was just making sure that it didn't fall into the crater.
Gotcha.
And
gotcha.
Linking that back to the robot and especially the math part of STEM, while a lot of the math that you use in the robot is, I guess, simple is a way to put it. Not simple per se, but like basic, like a lot of people have a good understanding of it. It's one of the most crucial parts, especially like angling things right. That's a very crucial part of the robot game.
So it may be easy because you're looking at numbers you understand, but the precise nature of how to utilize those numbers is the key.
Exactly.
Right. So when we do that, to kind of build on that, so when we're talking about wheel rotations, then they have to deal with circumference and pi. So they're multiplying numbers by pi all the time.
Like
and
apple, pecan?
Right. Pumpkin.
Pumpkin.
Tis
okay.
the season.
All right.
Pi
being the math equation, right?
Right. 3.14, blah, 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 blah.
159, Dad.
No, thanks. Okay.
At least take it out a few decimals, right? Okay, so I derailed you. Let's go back on to not only the wheel rotations, but pi. You were telling me about the math involved with utilizing that. So where were you going with that?
So that comes down to using a standardized wheel, because there's wheels that have different circumferences, and if you do 15 rotations on a wheel that is,
4 inches around as opposed to 3 inches around.
Exactly. And then not only that, but then there was also, I remember a few times a conversation between team members about whether they're using, metric measurements, or they're, if somebody wants to use inches, and like we know in America we're just automatically taught, the imperial system, and then, but to do it properly, then people were talking about, doing metric. So there's a back and forth. So a lot of real world challenges that they had to deal with. Cause I mean, I do that when I have to like find a socket, to undo a bolt.
Mm-hmm. Mm-hmm. And what did your team land on, Oliver? Did you stick with the imperial system, or did you go to metric? Or
we went to metric because we felt it was the most convenient, and a lot of the other teams use metric too. So it's nice to just, maybe if you're giving them tips, have a conversation, just like saying, "Oh, this many,"
Well, everything's so much more evenly divisible, right?
Exactly.
And in science, I think the standard is metric.
Yeah,
right.
Makes sense.
Right.
Yeah.
So you're going to go to state. Do you take the whole project the way that you've put it together right now and just recreate it over there?
So I'd say usually what we did last year with state is we kind of kept the entire project, what we did at the qualifying tournament, and we kind of revamped it, added some extra features to it, maybe flesh something out, look at what the judges gave you as feedback, and build on top of that.
Right.
Get 6 things or 7 things right instead of 5.
Right.
Yeah.
Yeah.
So I think the key that we found out is that going to the next step in competition is, if you've got mistakes, we can try to refine them. But I mean, it comes in right at the tail end of the holidays. It's a big time commitment to be involved in this. So we don't want the kids to burn out. Before going to state, we just kind of refine our presentation, make sure that the robot's running correctly and that everything's all lined up. But we try not to mess with anything.
Well, you know, one of the things that I'm really appreciating about what I'm hearing is that it has so much more to do with things outside of the robot actually functioning.
Mm-hmm.
You know, that you do have this problem, real world problem that you're solving outside of the fun aspect. I mean, because like you say, you know, the gateway into this is, I want to go and play with Legos. That you're right. As an adult, I want to go do that. I want to be on a team. Give me a task. I love Legos, you know?
Right.
But at the same time, we're getting beyond that into the humanity of it in this case with the housing mission that you chose. We didn't touch on the core values part for your particular project,
Okay.
right? That's the third
Right.
aspect of what you had to do, right?
So every team has to deal with the same set of core values. Discovery, you know, what they discovered throughout the course, and the judges would ask them those questions, like, throughout the course of your team's involvement in the program, can you give me an example of what you discovered?
And so this goes to the presentation part that you were talking about refining,
Exactly.
right?
Exactly.
They basically just want to know how you and your team, both of them, express the core values in what ways, and like how did it affect your life outside of robotics.
I think that's fantastic.
So how did it affect your life outside of robotics?
In a lot of ways, especially talking about the core values so much. I think a lot of times it's such a weird thing to say, but when someone mentions the word discovery, that is one of the prime examples of a core value, and they always kind of drill it into our heads. I mean, it's not a bad thing to think about a lot. Obviously, discovery is like a key part of life in a lot of ways, but when it's so weird, but whenever someone says discovery, I just think of robotics. It's
Right.
such a
I think it's Star Trek.
Yeah, right.
Yeah.
Or cooperation, which I think there came to a point where we all kind of loathe the word, but it makes a whole lot of sense, right? Cooperation and competition. Like, they want to foster competition, but in a way that doesn't exclude other teams, other members. So there were teams that state last year that just went around and, like, passed out candy, you know, or if one thing that I was really proud to see the kids do, not totally unprompted by any of the coaches, was when we had practice time up at the tables during competition, if they saw that another team was maybe having a difficulty, or we found out that there were certain rules that changed from the previous year, that we just were more than happy to share that information with them and not kind of hold it to ourselves and hope that they fail so that we can win. I think that was drilled into us, and they have like roving judges along the floor, just making sure that it's all about the spirit of teamwork and cooperation, and not just trying to win at all costs, you know. And like I said before, it's probably easy for a lot of these very successful parents to come in and want their kids to be successful in their own right, but kind of take over some of the project and some of the building. So when the kids go in as a team in front of the judges, the coaches for the most part are excluded, so that we're not there to coach them on their answers, you know. So they'll ask them questions like, "Oh, so, you know, can you tell me about how your team worked together, or how there are times where you guys didn't work together, or how you solved problems?" And I think it would become evident to the judges where the parents kind of had control over the group rather than the kids having control.
By the way that they answered.
Correct.
Yeah. Yeah. Well, that's great. That's great. Okay, anything that we didn't get to talk about today that you guys wanted to make sure that you said? Have you started your podcast?
We haven't. We've got everything in gear. We're just trying to figure out the format of the podcast, and yeah, just kind of the structure and just kind of taking it bit by bit.
What's it about?
So it's going to be called the Dog and Tiger Podcast, because that is our Chinese astrological sign.
Okay.
I'm dog.
He's dog,
Dog,
I'm tiger. And what it's going to be is kind of like a clash of generations. So I'm the older generation, and I'm going to, since I have a culinary background, where I'm going to introduce him to new foods every show and see what he thinks of them. And Oliver is going to introduce me to things that are happening on YouTube or video games.
Nice.
I
like it. So we will make sure and get information about the new Dog and Tiger podcast as soon as it's available. We'll share it on our website. All right. Well, Oliver, Jim, thank you both so much for being on the show today. I really enjoyed visiting with you, and congratulations on your championship status, and good luck in your upcoming competition.
Great. Thank you. Thanks for having us.
You bet.
Thank you.
Joe, I really enjoyed that episode. I don't think being a Lego robot would be a bad thing at all.
No, STEMBot, I don't think it would be, and I think you'd be great at it. Hey, everyone, thank you so much for tuning in. I sure enjoyed having that interview. Thank you again to my guests, Jim and Oliver Yue. And thank you, Michael, for being in the studio with us to do that recording. All right, everyone, that's it for me. I hope you have a wonderful new year, whatever year you're listening to this podcast, and we'll catch you next time. Thank you for listening to the STEM Punks podcast. I'd like to thank our sponsor, Cottywomple Creative. What's a Cottywomple? It's a purposeful journey towards a vague destination. You can see their work at CODDIWOMPLE creative.com. I'd also like to thank our patrons on Patreon. And today's episode has original music by Duncan Crummell. You can learn more about him at duncancrummell.com. And as always, you can find more about STEM Punks at stempunks.com. Now that we've got all the .coms in there, I guess that's it for today. Thanks for listening. Links in the show notes.
And I love you people too.
I'll be back.
So are you in Hood River because you're an engineer? Or?
No, absolutely not. I was in sales for many years, and I was just working your typical job, driving my car, doing sales meetings, having phone calls, conference calls, and I just felt like one day I'm going to die in my car from some kind of coronary event.
I can completely relate.
Yeah, and I was like, life is too short, especially with my dad passing away a couple years ago, which was kind of the onus because he was always a dreamer. And I kind of see those same characteristics in myself, where the next big thing was kind of down the road, but you never kind of got the gumption to go grab it. So after he passed, I was like, well, I don't want to be that person who's always trying to grab the golden ring but never getting on the merry-go-round. So I just said, forget it. My wife and I both quit our jobs that we were doing very well in, and we decided to make a move out west. And originally we had thought about going to California, but if we moved there, I would definitely die in my car because I'd be in my car for the majority of the day.
That's true. That's true with traffic like it is.
Right. And then we headed up north, and then once we arrived here, which is where my brother-in-law had lived for the past few years, I could just breathe. It was just kind of like an epiphany, a moment where I was like, hey, I think we found the place.
Right on. Well, I know that speaking from somebody who's had the opportunity to work with you in many different ways, artistically and otherwise, I would say that the Gorge is definitely lucky to have you here. I don't want to go without saying that.
So, Jim, what do you do when you're not coaching?
When I'm not coaching, I'm thinking about not coaching. When I'm not coaching, I am a chef and a consultant at one of the local restaurants that just opened up recently. And
name?
It's Grateful Vineyard up in Parkdale.
Yes.
Yeah.
I was just up there.
Yeah, got great pizza. Good
great
people.
pizza. Good people, great pizza, wonderful location. Yeah, I definitely recommend getting out there to Grateful
the
Vineyard.
little outside area.
Yeah, it's really nice. It's and that's new as well. So they just opened in May, and the business has been going gangbusters.